Hey everybody, welcome back. Today we are going to be talking about 2.6, the last lesson in chapter 2. Today it is going to be properties of equality and congruence. If you can pull out that handout that I gave you earlier today, that would be great. That has the different properties. Okay, so on that first side of the handout, we're talking about the properties of congruence. When we look at the properties of congruence, there are three of them. One being the reflexive property of congruence, the next one symmetric property of congruence, the third one transitive property of congruence. One thing that I do want you to know, whenever you are dealing with a property of congruence, they will always have the congruent symbol on them. Okay, so whenever you see the congruent symbol, make sure that you are marking it down as a property of congruence. Okay, property of congruence means congruence symbol. So get to know these three properties. Reflexive property being they are the exact same on each side. They're reflective of each other. You can definitely see that line segment EF is congruent to line segment EF. They're the exact same on both sides. Symmetric property of congruence, meaning they're just flipped. Angle 1 is congruent to angle 2. Then angle 2 is congruent to angle 1. Transitive property of congruence, it's just like saying if A is congruent to B is congruent to C, then A is congruent to C. That transitive property that follows long notice. You will see a few if-then formulas down here that we talked about in 2.5. Okay, then here are our properties of equality. This is going to be on the back side of that sheet or the back side of the handout that I gave you. Okay, again, these are going to be with our equal sign. Okay, notice there are three here. You will see reflexive, symmetric, and transitive property of equality. They're the exact same three properties as congruence, except we're dealing with an equal sign instead of a congruent sign, if you notice right here, okay, on each of these. Addition, property of equality, you can break that up. If A equals B, then A plus C is equal to B plus C, adding to each side. We deal with the addition, subtraction, multiplication, and division properties of equality every time we do a simple equation like 4x is equal to 12, because in this would be our division property of equality. If we divide each number by the exact same number, which you will see down here, okay, then x is going to equal 3 and we are going to get our answer. We deal with these properties of equality all the time in each one of our algebraic expressions and algebraic equations. Okay, so we're just going to focus on the first four example problems, looking into it, see if you can name the properties of congruence or the properties of equality. Again, you are going to need to know this stuff. You are not going to be able to use this handout on your test. Okay, just remember, numbers are equal and figures are congruent. 90 is equal to 90, however, angle 1 is congruent to angle 2. If it is a figure, geometric figure, we use congruent symbols. Okay, again, angle 1 is not equal to angle 2. It is not true. Okay, it needs to be angle 1 is congruent to angle 2. Just watch your congruent symbols. Alright, so here's our first problem. It is angle QRS is congruent to angle QRS. Forgot right here. These are all going to be symbols. Okay, because those are figures. And then at the bottom, 94 degrees is equal to 94 degrees. AB is congruent to CD, and CD is congruent to EF. So AB is congruent to EF. I want you to please write these down and try to write down which property the statement illustrates. Notice you do need to explain the property and say property of congruence or property of equality, because when they're talking about that, there are two different things. Alright, so angle QRS is congruent to angle QRS. Notice it is the exact same on each side of the congruent symbol. So that is going to be our reflexive property. Just going to put property of congruence. I'm just going to put a congruent symbol, and you can do that. Definitely break it down instead of writing it all the way through. You can write symbols. Next one, DE is congruent to GH. So GH is congruent to DE. When we look at that, it is a direct mirror of each other. Okay, it means that is our symmetric. And which property are we talking about? Because we have a congruent symbol on each side, it is symmetric property of congruence. Okay, 94 is equal to 94. We're talking about a single measure. And because we're talking about a single measure, but this is the exact same property as number one, except for this has an equal sign this time. Okay, so because it has an equal sign, it is the reflexive property. However, the equal sign changes a little bit. It's the reflexive property of equality. Because it has an equal sign instead of a congruent sign. Okay, then lastly, AB is congruent to CD and CD is congruent to EF. If that is true, then AB has to be congruent to EF. There's only one property that makes that possible, and that is going to be your transitive property. Now the question is, what are we talking about? Transitive property of what? It is the transitive property of congruence, and can you explain why? I hope so, because we're talking about congruent symbols. So transitive property of congruence. We have congruent symbol at the top, which means we have our congruent symbol in the answer. Fantastic. Alright, here's our new problem. It says in the diagram, C is the midpoint of XD and D is the midpoint of CY. Show that XC is equal to DY, and that should be is congruent to DY. Okay, now when we look at these, I'm going to walk you through this very first one. We're going to come up with a little explanation using logical arguments. Alright, so our very first thing that we need to know is going to be, what does it mean to have a midpoint? Because that's the key in this statement. C is the midpoint of XD and D is the midpoint of CY. That's the biggest key in how we figure it out. So my question to you, what is a midpoint? What does the midpoint do? Well, I hope you're thinking, well, it cuts the segment into two even segments. And that's exactly what it does. So I'm going to look down at XD. Notice that C is the midpoint of XD, which means it cuts XC and CD into congruent segments. We know that because C is the midpoint. Alright? So XC, we know, is congruent to CD. Now, the next piece of our information, D is the midpoint of CY. Well, if D is the midpoint of CY, then when we're looking at this entire segment here, CY, then CD needs to be congruent to DY. Why? Because D is the midpoint here. It's the middle, which means it cuts it into two even segments, which means CD is congruent to DY. Now, I want you to look at what we just wrote down. We have XC is congruent to CD, and CD is congruent to DY. Well, that it has a property written all over it. Can you tell me why then is XC congruent to DY? What property makes that true? It is the transitive property of congruence. Okay, If you look back on that handout again, you will notice that the transitive property gives that exact statement where it says on the handout PQ is congruent to RS and RS is congruent to TU. Because of that, then PQ has to be equal to TU. That is the exact same thing you see here. XC is equal to CD. CD is congruent to DY. We can substitute dy in for CD because of that, so XC is congruent to dy. Using your logical arguments and your property here to come up with a great argument. Alright, last one. I want you to try this one on your own. Please remember back as to what we talked about maybe earlier in the chapter, maybe even last chapter a little bit. Think about it, because all of these properties and all of these postulates and all of these theorems are going to be piling on. So make sure you are studying each one of those. Okay, it says angle 1 and angle 3 are both supplementary to angle 2. Show that angle 1 is congruent to angle 3. You're coming up with an argument. Why do you know that angle 1 is congruent to angle 3? We know that it's true, but explain why. So give it a shot now, pause, and try it. Alright, so the very first thing I'm going to start off to do is I'm going to get the definition of supplementary. Okay, we know, what does it mean to be supplementary? Well, we know that the two angles add up to equal 180. If 1 and 3 are both supplementary to 2, then angle 1 plus angle 2 equals 180. Okay, now do the same thing with angle 3. Angle 3 plus angle 2 is equal to 180. Okay, if we substitute it, okay, so now you can tell that angle 1 plus angle 2 is equal to 180 and angle 3 plus angle 2 is equal to 180. We can actually substitute this part in for our 180, because if they both equal 180, they equal each other. So angle 1 plus angle 2 is equal to angle 3 plus angle 2. Okay? If you remember this goes back into a certain property. If you remember that property, think about it, think about it, think about it, think about it. Alright, it is going to be your addition property of equality. So that is our addition property of equality. So we now have angle 1 is equal to angle 3, because they are both, when added to angle 2, they are the exact same on both sides. So angle 1 plus angle 2 is equal to angle 3 plus angle 2. That tells me that angle 1 must be equal to angle 3. However, these are figures. So in the end, we don't use that symbol. We use our congruent symbol, because we're not talking about numbers, we are talking about figures. So you can use that equal sign all the way down through, but just make sure we end up with that position right here. Remember, this step is all based on the addition property of equality. Okay, which leads into that step. If you have any questions about the properties, how they match up, please, please, please ask me tomorrow so I can cover it. Alright, thank you very much. You guys have a great day.